Hello, and welcome to Taking Apex for a Test Drive from Breault Research Organization. My name is Rob Purcell, and today we'll be going through and showing off Apex. Uh, if you're following along, be sure to have SolidWorks with Apex installed. Otherwise, feel free to sit back and enjoy the show. Uh, Apex follows the four-step workflow. These steps will come up as we go through. I'll explain them as they go on. The first thing we're going to talk about real quick, just to show off some stuff, I will kind of show off the differences between the general SolidWorks UI and the Apex UI. For those familiar with SolidWorks, this should look fairly standard, but if you have a keen eye, you might have noticed there's a few additional tabs up here. These tabs are what are added through Apex, specifically the Optical Geometry tab, the Sources tab, the Trace tab, the Analyze tab, and the Design tab. These will come up later on, but just important to note, the other big change is over here is the Apex Optics Manager. This is where all of the kind of Apex work will be done. Again, a lot of this will be explained in detail further on, but just good to know where everything is. Alright, so first things first, before we do anything else, we're going to create a folder on the desktop where we'll put all our files for today. You can put it anywhere, but I'm going to put it on the desktop. Just create a folder, call it test drive. We'll be using that. And after that, we can go ahead and get SolidWorks up and running. Once we've got SolidWorks open, let's go ahead and create our first part file. So go ahead and press new. Normally in SolidWorks, this is the tab that opens, but you'll notice there's a tab here called Apex. There's a few other different options. We're going to pick the millimeter NC file. Go ahead and pick that. That'll be our part file for today, and we'll have a new part file created. And once that part file is up, if you're, again, familiar with SolidWorks, this looks pretty standard, but again, there's one additional tab here, the Optical Geometry tab, and of course the Apex Optics Manager. And with that, we have officially reached step 1, design and verify the geometry. Obviously, as the title of the step suggests, this is where we will be building all of our part files for the project. This will be mostly SolidWorks, so it might seem a little redundant if you know it, but there will be a bit of Apex in there. So here we are back in our part file, and the first thing we're going to do is create a sketch on the right plane. So I'm going to go up here and click sketch. I will click the right plane, and we have started a sketch on the right plane. Now this first part we're making will be the parabolic reflector that you saw a little sneak peek of in the beginning. So what we're going to do is go up here to, here we go, parabola right here. And we'll click that. We will put the first point at the origin here, and then we will move it along this way, like so, and then the design will look like this. And what we need to do next is put 2 points on here to make a little tangent arc. We click and click again, and there's how our parabola starts. Next, what we're going to do is start defining a couple relations. So the first thing we're going to do is go up here and click Add Relation, clear this selection. What we're going to do is click the origin, which is where the focus is at right now, and then we'll click the vertex here, and then we'll make this a horizontal relation. Now those will stay on axis. The next thing we're going to do is make another relation, and we're going to click, if something ends up here, be sure to clear it again, but we're going to click the focus again, And then we're going to click this endpoint down here. And this will make a vertical relation. And then we'll click OK. So there's our first couple relations for our parabola. After those relations are set, we're going to smart dimension and set the size for our parabola. So we'll go up here to smart dimension, and we will click the focus at the origin, and we'll click the vertex, and then we want this to be equal to 2 millimeters. This will resize our parabola. The next measurement we need, so that's okay. Another smart dimension. We'll click this endpoint, and we'll click this endpoint, and we want this to be 75 millimeters. And so now our parabola is sized out properly. Alright, up to this point, this is where we should be at on the test drive. The next thing we're going to be doing is making the parabola a full surface, not just a line segment. So here we are again, back in the part file. What we're going to do is go up here to line and click the drop down arrow, and we're going to click center line. We're going to put it at the origin and then draw it out a little bit under our parabola. I pressed escape there just to make sure our line is set. After that, we're going to go to the surfaces tab up here. We're going to click revolved surface. It should automatically fill, but if it doesn't, your axis of revolution will be that line you just made. You'll press OK, and we have a good looking parabola, or parabolic reflector rather. And just to solidify that, we'll go over here to where it says surface revolve. We'll right click that. We'll click feature properties here, and I'll call this the reflector. Oops. Meant to change the description too. We'll call this parabolic reflector. Great. So now it says reflector over here. So that was all fairly basic SolidWorks, but here is where we're going to do our first bit of Apex. So here we are again, back in our part file. We'll go over to the Apex Optics Manager that I pointed out earlier. Right here we see our part that we just made, and I'll right click that and I'll press set coding. We'll go down here to ideal coding and expand that, and we'll click reflecting, and we'll click perfectly reflecting and press OK. So now our reflector is actually reflecting. And with that, our reflector should be done, so we can go ahead and save this, and we'll put it in that folder we created at the start. We'll call it reflector. We can add a description if we want. We'll call it parabolic reflector, and we will save it. So there is our first part officially completed. Alright, if you've been following along, here's where we should be on the test drive. This is page 32. The next thing we'll be doing is creating a target surface, which is basically just a target that our reflector will be aiming at. Alright, back in SolidWorks, here's our finished reflector. We're going to go ahead and minimize this. You can close it if you want, but we'll need it later, so it's good to keep it minimized. We'll go back up here and create a new part. Same type of file, millimeter ANSI. Press OK. And here's our new part. we'll go up here to sketch. We'll click sketch. This one we want to put on the front plane. So here we are, sketch on the front plane. Want to go up here, click this drop down arrow, click center rectangle. And we want to put this right at the origin and make as close to a square. Again, we'll dimension this out in a second. So there's our start of our target. We'll click OK. Next thing we're going to do is dimension this out. This is same as before. We'll go up here, click Smart Dimension. We'll click this. We want this to be 100 millimeters. And then instead of smart dimensioning it 4 times, we'll go over here and click Add Relation. Make sure this is clear before picking anything. So we want top and left side, and we will click Equal. Next, we once again want to make this a real object and not just a sketch. So we're going to go to Features. We're going to click Extruded Boss Base. 10 millimeters is the default, but that's what we want to set it to anyway. And we'll click OK. And now we have a full target. Okay. Again, just like last time, we're going to go over here and right click and go to the feature properties. We're going to call this the target. I'll describe it as square target. We'll click OK. Now it says target over here. The next thing we're going to do is some more apex again. So once again, we'll go over to the Optics Manager and we will right click the part. We're going to put another coating on. Again, ideal. But instead of being reflecting, we want this to be absorbing because this is where we're sending our light. Perfectly absorbing. We'll click OK. And now that should be set. And we're going to save this file in the same spot we put the reflector. We'll call this target. If you want to add a description, you can. Call it square target. And we will save it. And then we're going to want to minimize this as well. Alright, as of now, we should be here. This is page 42 on the test drive. The next thing we're going to be doing is combining the parts into an assembly file. Back in SolidWorks, we're going to go up here to New again. In the Apex tab, we're going to pick an assembly. We would like millimeter ANSI, this one right here. And we're going to click OK. This is going to create our assembly file. The first thing we're going to do is click our reflector here and click OK. This has put our reflector into the assembly file. To make this easier to view, we're going to go up here and click View Orientation, drop down. We want the left view. And so here is our reflector. Something important to notice, our reflector is fixed. That's what this F in parentheses means. We want this because this is where we want our reflector. We're going to go over here to the Assembly tab. We're going to click Insert Components. And this is where we'll put our target. And we'll press OK. Obviously, this looks a little weird, and this isn't where we want it, but we're going to deal with that now. Okay, I'm going to zoom out a bit. You can do this by scrolling, but there's a few other ways to do this. As I mentioned earlier, the reflector is fixed, but right now so is the target, which is not what we want. So we're going to right-click that, and right here where it says float, you're going to click that. Now the target should be able to move. What we're going to do to set up this is use mates. So what we're going to do is go up here and click mate. And so right now the planes of the reflector should be lined up with the planes of the assembly, as it is in the fixed default spot. So what we're going to do is click this drop down arrow next to the target, and we're going to click the front plane of the target and the front plane of the assembly. And what we want is right here, this little distance one, and we want this to be 250 millimeters. Oops. We're gonna flip that because it put it the wrong direction. There we go. Now it is the right distance away, and we'll click OK. That's our first mate. Now we also want to be sure it's aligned in the other directions too. So this one we're going to press the top plane of the target and the top plane of the assembly. And this one we want to be coincident. And we'll click OK. And then we'll do the same for the right plane and the right plane. Also coincident. We'll click OK. Then we can close out the mate menu. Alright, as you can see, the system is now fully defined. So we'll go up here and save it in the same folder that we were in before. We're going to call this the illuminator. And as for description, I'll say parabolic illuminator. And then we're going to save this. And this is the end of step 1. Now that we've finished designing and verifying the geometry, we're going to move on to step 2, design and verify the sources. This is where we should be in the test drive. This is page 54. And from this point on, we're going to be in a lot more Apex territory than SolidWorks. So here we are, back in our assembly file. First thing we're going to do is go over here to the Sources tab. And we're going to click LED up here. We should have LED already selected here. We're going to scroll down to LW3C. This is the LED we are looking for. And then we'll press Insert. Pressing Insert has opened up the light source wizard. Right now we're just going to take the default settings, verify that it says LW3C up here, and we'll press Next. These should be the default settings. If they're not, feel free to change them to match this. And we'll press Finish. This will generate our reset. Next, we're going to real quick right-click on the reflector and press right here. It says Change Transparency, and we'll press that. Now we can see the light source through the reflector. Our next step is going to be positioning the LED. So we're going to go over here to the Assembly tab. We're going to click the light source here. We're going to click Move Component. Make sure this is free drag. And then we're going to click it and drag it just so that way we can more easily access it. We'll click OK. Real quick, what we'll do is we'll rebuild the document just to be sure everything is okay. If you didn't see, that's this one up here. And the next thing we're going to be doing is applying mates, similar to how we did with the target. So the first mate that we will do, go up here, click mate. We're going to zoom in a little bit. We want this part of the reflector right here. I'm going to rotate here using middle mouse. I'm going to zoom in a little bit. And I want this part of the LED. This might look a little weird, but that's okay. We're going to fix that right now. We want to open this tree again. We can close the target tree, but we want to open the source tree. There we go. And then what we want to do is click the top plane of the source and mate it to the top plane of the assembly. click OK. And then we want the right plane of the source, and we want to mate that to the right plane of the assembly. And we'll click OK, and that looks a lot better. We can then close out the mate menu. With that, we can zoom out again. Let's go back to this view. And we can save our document. Save all. There we go. And that is it for part 2. Now that we've finished designing and verifying the source, we can move on to step 3, trace the rays. This should be the page that we're on for the test drive. This is page 67, if you're following along. Back in SolidWorks, in our assembly file, we're going to move over to Project Settings right here, and click the All Settings button. This will open our Apex Settings menu. We're going to want to click Ray Trace Display. And we want to do display nth ray, where n is 1,000. Then we want to go over to ray arrows and mist rays, and where it says distance to extend rays in 3D, we want to change that to 250. Then we want to click OK. And that should be the settings we need for this ray trace. From here, we're going to want to go to Trace. And where it says Trace Rays, we're going to click that. It'll take a second to load. And there are our rays for this system. And this is all we needed for step 3. Now that we've traced our rays, we can move on to step 4, perform the analysis. This is the page we're on the test drive. This is page 71, if you're following along. So here we are back in our assembly. What we're going to do, I'm going to zoom in a little bit and rotate. We want to click the target, main surface, and we're going to go over to Analyze. What we want is a radiance. We want to make sure selected surfaces is what is selected, and we want to turn all of these on, and then we want to set the data resolution to 101. Confirm that, and we're going to let it run. And here we get our irradiance plot, as well as our spots position. If we go back to the model, we can see that the spots position actually shows up in our SolidWorks model now. If we go over to the Optics Manager, we can see all of the results are sorted here on this tree. If we ended up doing another ray trace, we could go back and forth between the two if we wanted. But we've actually got a couple more things we can do. So what we're going to do now is we're going to right click on Result Set Irradiance and click Process Data Set. We want the default settings to average and 1, and we click OK. With the new average selected, we're going to go to the Analyze tree, and we're going to click Picture Plot. And here we have our average picture plot that we can compare to our irradiance plot. Pretty similar. Next, we're going to go back to the model, make sure the front face is still selected, and up here we're going to click Radiant Intensity Cosine. Be sure selected surfaces is the one selected, and then we want to turn all of these on again. Make sure this is still 101, and then we're going to approve that. And here's another intensity plot. We also have this one. And then we can process this again. So right click on angles 1 here and click process dataset. And we'll get another average here. And then we'll click this average and we'll get another picture plot. And so here's our average. The next plot we're going to make, we're going to go up here and click distribution section. We want the z-axis. And then we can approve that. We get a distribution graph. And we can go ahead and save this. And all of this data will stay on this assembly file anytime you reopen it. Even if you do another ray trace, you can go back to this one at any time. And with that, that's the end of the Apex test drive. Alright, I hope this has been a useful, albeit somewhat brief introduction to some of the things Apex has to offer. And thank you so much for watching.